All right. So here we got geometric sequences. You've seen them already. We just haven't called them this yet. These type of sequences will have their own rules, just like arithmetic had their own rules. But a geometric sequence occurs when each term is multiplied by the same number each time. Okay? This number is called the common ratio. And we use the symbol R for it. Okay? Second, when you need to find the ratio, so to find the ratio, you divide any term by the previous term. So for example, if I gave you this sequence, 1, 5, 25, 125, 625, etc. And the question is this geometric? If so, what is R? This is where your calculators come in. If you don't see it, you can use your calculator, but some of you might be able to look at this pattern right away, and you know it's going to be geometric as long as you can multiply by the same thing to get each number. You know how for arithmetic we were always adding the same number or subtracting the same number, right? It's the same idea, but for geometric it's we're multiplying by the same number, okay? So do you see what number we're multiplying by each time? Five, okay? And you should check every single term, okay? 1 times 5 is 5, 5 times 5 is 25, times 5 is 125, times 5 again is 625, okay? If you're not sure, that's what the calculator will help you determine. So this is geometric. And to find R, this is what I mean by you can take any term and divide, okay? If I look at 25 as where I'm starting, and I want to find the ratio, I would just take 25 and divide it by 5. You just go one back. Does that make sense? Or 5 divided by 1. Or 125 divided by 5. Or 625 divided by 125. All of those will give you the same ratio, which is 5. Okay? Does that make sense? Are there any questions on that? Okay, try this one on your own, and maybe the calculator might be necessary, maybe not. Hey, how you doing?
Do you Dixon?
I do, but not today. She hasn't. She's absent.
Oh, okay.
Yep.
Thank you.
Mm-hmm. Same questions. Okay. So is this geometric? If so, tell me what the ratio is. Okay, so take a minute, think about it. Sorry, normally I'd walk around and kind of help as you guys were working, but I don't want this to disappear. Once it goes on standby, it stops recording, and I didn't know that, so I had to like re-record a video 3 times. So I'm just gonna make sure this is recording the first time. So I'm kind of looking to see if you guys are writing or punching stuff in the calculators. I'll wait a little bit. Now, again, some of you might look at this and go, yeah, that's geometric, and you kind of figured out right away what the ratio is. And others maybe might be looking at this going, you know, that looks kind of weird, I'm not sure. Okay, here's what you do. Your test is basically, and those of you watching on YouTube, what I'm doing is typing in every one of these in the calculator. So in order for this to be geometric, there needs to be a ratio that's in common all along the sequence, right? So the first way I would check is to take -1 divided by 3, and we get that. Okay? Next, so I took this one divided by that one, I got -1/3, if you convert it to a fraction, right? So if this is geometric, no matter which pair I take, so if I go now to this one, what's 1/3 divided by -1? You get the same exact thing, right? -1/3. If I take this one, -1/9, and divide it by 1/3, let's do that. -1/9 divided by by positive 1/3. You get the same exact thing every time. You guys see what I'm saying? So what is the ratio here? The ratio would be -1/3, okay? Because no matter which of these you do, let me use the eraser. So whether you do this number, whether you do this number divided by this one, -1/9 divided by 1/3, Or if you do 1/3 divided by -1 or -1 divided by, all of them give you the same ratio, -1/3, okay? So yeah, it is possible to have a negative ratio, and what's going to happen, you've probably noticed, it switches back and forth from positive to negative each time. So that's kind of what's going to happen if you see that, okay? Any questions on that? Okay. Here's another example for you to try. Find the second, third, fourth, and fifth terms of a geometric sequence with first term of, let's do 2400, and a ratio of 1/4. Okay, so I'm asking you to find the next 4 numbers in the pattern. Josh, you want to borrow this?
I'm using one right here.
Okay. So if you got a graphing calculator, this is the nice thing about knowing how to use it. So how do I find the next number? I start with 2400, and then what do I do with R? How do I use that 1/4? Multiply. So you take times 1 divided by 4. Now you get 600. Okay, so we took 2400. I'm just writing all the steps down. Times 1/4, and we got 600. To find A3, you would then take 600, or here's the thing on the calculator. If you just press enter, if you just press times, rather, you see this little answer thing pop up. It knows to use the previous answer. So now if I take 600 times 1/4, I get 150. And here's the nice thing about this. So if you needed a whole bunch of terms, you can just hit enter over and over and over, and now it speeds up the process. You see what I'm saying? So now you don't have to keep typing it in if you're doing it that way. But anyway, let's see, where was I? 150 was the last one I had, right? So then the next one would be 37.5. And the last one, A5, would be 37.5 times a quarter, which we already did on the calculator. But that was 9.375. Okay. Everybody good with that? Okay, so these questions aren't too bad, right? You just kind of have to know what everything means. And just like with arithmetic, here's the general rule for geometric. So we have a sub n. Okay, and maybe you can figure this out, but we started by taking our first term, which is 2400, right? So I'm going to say A1 is involved. And then what did I do? I multiplied by the ratio. Okay? And this ratio gets multiplied a certain number of times depending on how many we need. For example, you can even see it right here. Look, to get my final answer for the fifth one, I needed to multiply by a quarter 1, 2, 3, 4 times to get there. Does that make sense? To get my fourth one, I needed to multiply by a quarter a total of 3 times. Does that make sense? In other words, this ratio is going to get multiplied by 1 less than whatever n is. Okay, so if I wanted, for example, to find the 10th number in the pattern, I would have to multiply the 1/4 a total of 9 times in there to get that. Does that make sense? And rather than doing it one at a time, now we have a shortcut. Okay, so this is your shortcut. And so here's how you would use this, for example. Okay. Let's say I want to find the 20th term of a geometric sequence. And let's just I'll just give you the sequence. Let's start with 2. 2, 3, 4. So here's your geometric sequence. We have the first 4 terms given to us. We're trying to find the 20th one. And let's go ahead and round to 2 decimal places for our final answer. Excuse me. All right, first, let's find the rule. Okay? So we're going to use this formula up here. Use this formula. I'm going to write it down again. And I'm going to fill in what I know. So, looking at this sequence, what is A1? First number, or the first term, is 2. Then we got to multiply by the ratio. which they didn't tell you, but you can figure it out. How do I find the ratio in this sequence of numbers? What's one calculation that we could do? There are 3 different ways to calculate the ratio, and they all lead you to the same answer. Alex, what do you think?
Divide.
Divide what?
3 divided by 2.
So 3 divided by 2. What's another option that would give me the same answer? I could do 4.5 divided by 3 if you wanted to, right? Doesn't matter which ones you do. Obviously, 3 divided by 2 is certainly easier because the numbers are right there in front of you. But you can do any combination, any pair, as long as you take wherever you start and then divide it by whatever's before it, right? That'll give you the ratio. Doesn't matter how you do it. So, now that we know what the ratio is, plug it in. And here's your formula. So this is the rule. Okay? So now, to find the 20th term, this is just like what we did with arithmetic. You guys see that, right? Except it's just a slightly different formula. Okay? To find the 20th term, I do 2 times 3 over 2. Plug in 20 into the exponent. And you get your answer. Okay, and again, if you have a graphing calculator, okay, don't mess around making mistakes. I would just type it in exactly the way that you see it here. So 2, and if you forgot how to use the fraction button, remember you can go alpha y equals, and that gets you to option number 1, which gives you a little fraction template, right? And then I would even put parentheses around that, just like you have on your page. And then fill in exactly what is in front of you. And now you need an exponent, which is 20 minus 1, which obviously is 19, but you can literally type it in exactly like this, and you get your answer. Okay? 4,433, and it said to round to 2 decimals, so we'll go 68. Okay? Is everybody getting that same answer? Okay, because if you're not, we got to make sure we're typing it in correctly. We can work on that. But like I said, this stuff isn't hard. I really don't think it is. And I think you guys understand what's going on, especially when I go through it with you. But then as soon as you're on your own, some of you just decide, all right, I get it. I'm cool. And then you don't practice.